Good morning to all. I am Dr.C.Senthilkumar, alias Dr. CSK, Associate Professor, Department of Mechanical Engineering. I am teaching the subject 23 MLB 302 heat and mass transfer. So already we have seen the concept of heat and mass transfer modes. So what are the three modes? Can anyone say what are the three modes of heat transfer? Convection, convection, and radiation. So based on the design thinking concept, the course is separated from the physics, which is a thermofluid subject separate course. So what are the stages of design thinking? What are the stages of design thinking? Empathy, refine, ideate, prototype, testing. So these three are five stages of design thinking. These five stages of design thinking gives us enormous idea to formulate a project, to formulate a work, to formulate a case study, to analyze the case study, to study the further subject. So based on the empathy, we have made the PowerPoint presentation on modes of heat transfer. Now we are seeing about the convection mode. So what is meant by conduction? Can anyone volunteer say conduction? What is meant by conduction? Conduction means
Heat transfer.
transfer of heat from
Solid to
solid to solid. 1.2 another point, solid to solid. So what is the mechanism behind the conduction? It is the Fourier law of heat conduction, thermal conductivity, and the mechanism and modes of heat transfers are nothing but the lattice vibration, free electrons available in the system. These are made by the empathy and the define part. Empathy and define part. They made an idea that we have made presentation. We have made an idea to present the concept of convection. How to make the presentation of convection? We have seen in the class also in a presentation. So that idea is made as a prototype in a presentation and it is evaluated through your ideology and observation. So this is the design thinking based explanation of convection mode of heat transfer. Convection mode of heat transfer. Just before we have seen what is conduction, what is the important law governing equation governing conduction. What is the equation governing conduction? Law governing the conduction. What is the law governing the equation? Conduction. Fourier law of heat conduction. Similarly, they made empathized. They empathized the Einstein design thinking concept on the convection also. They said the governing equation for convection is Newton's law of cooling. Newton's law of cooling is the governing equation of convection. Can you say that equation? Can anyone volunteer say the equation of convection? Stand up and tell me.
Q equal to H, small h, capital A, delta T.
So here H is the heat transfer coefficient. H is the HTC, heat transfer coefficient. Its unit is watts per meter square Kelvin. Watts per meter square Kelvin. A is area, delta T is change in temperature or difference in temperature. So this is what the governing equation of convection. So based on the design thinking concept, I have elaborated already in the presentation about the modes of heat transfer, conduction, convection, radiation, and you people voluntarily done explanation on conduction with the concept of case study. Now I am expecting few volunteers to explain about the concept of convection with whatever you prepared. I am calling the volunteers from the class based on the design thinking concept. Please, volunteer, you are volunteer. You introduce yourself and a recap.
Hello all, myself Palak from Mechanical Department. So, as sir said, what is convection? Convection is a process of heat and mass transfer. It's due to the motion of fluid which is liquid and gases. For example, heating the water with the help of pot. So this involves mainly two mechanisms, which is molecular diffusion and the bulk fluid motions. Now we will deeply go into the convection with the help of descent digging approach.
So you can think of whatever you did, and you can solve other ones.
So we learned about what is convection. So as Thursday, the convection is the process of transferring the heat with between the solid part and the fluid part. So I will call one of the volunteer to explain more detailedly with the help of design thinking.
Sir, Magesh, as Palak explained about what is the convection process that has happened by the fluids. Let's see it completely by the design thinking framework. As part of what is design thinking, it is used in many of the industries to solve the problem. Now, in the thermal case, we are using it to solve the to understand what is convection. As design thinking framework have 5 stages: empathy, define, ideate, prototype, and test. Let's see what is empathy. The empathy that we have is to understand what is the convection process that is happening by the and defining it by the Newton's law of cooling. The testing happens by the Joule Thomson method, which explain fully about the convection process that happens. And the prototype which we experience in the real life, those are the prototype and testing methods that will be the Joule Thomson explained by the another volunteer.
So you have a team of volunteers. Please come and remember.
So, while coming to the design thinking based explanation of convection. So myself, Harikar, I'm a mechanical student. I'm doing my third year over here, SNS of Technology. So this is the topic of the heat and mass transfer. And the basic idea is modes of heat transfer. It comes to be coming under the convection as well as radiation. This is the basic principle of heat and mass transfer. In that we are going to explain about the convection, how it goes on. As the previous colleagues have said about the convection, we are going to explain about the convection. So convection takes place with the thin layer medium of the fluid. The heat transfer takes place. So I am going to explain about the Joule-Thomson effect. Basic thing is about the Joule-Thomson, how it goes on the convection. So I need, based on the DT thing, we have to make some explanation about it. What is convection? In simple word, what is convection?
Heat transfer from solid to fluid.
Good. Solid to fluid. Very good.
Okay. Solid to fluid, the heat transfer will take place. So I will explain this concept. You have to say where the convection will take place. Okay. So here there is n number of gas. From this case 1 to this case 2, gas particles will transfer. So that by that time, what will happen? From one case to another case, the area will be different. This will be the high in range, but this will be low in range. The area will be different. This is the question I will be giving. As per the design thing, we have emphasized what is the empathy part. Then we have defined this ideology. So we have to ideate. The area will be different in this stage. So while prototyping, what will be happening? Can anyone guess? Here's a number of gases there. Here certain gases there. The gas will differ from here to here. There is a casing over here. From this flow to this flow, the gas will differ. So what will happen? Like any change in temperature or change in pressure, anything will happen.
Change in temperature.
Change in temperature. Change in temperature. Why change in temperature will occur?
Pressure increase.
Okay. Previously I have said there is a heat insulation over here. Pressure decrease. Like pressure once decreased, the temperature will be changing, right? Pressure once the pressure is increasing, pressure will change. Like it will be higher or lower. Pressure increase as na temperature will be higher or lower. Pressure will be increasing now. There is a pressure, it will be increasing. Then the area will be low. From here to here, area will be low, the pressure will increase. So temperature will increase or temperature will be increase. Temperature will be increase. So pressure increase now, temperature will decrease. Pressure increasing now, temperature increases. So this is the common ideology. So how the heat transfer, the convection mode will be defined over here. How convection can take place here? Yes.
When the heat transfer is taking to the fluid, when we are
No fluid is taken over here, only gas here.
Also, gas can able to transfer to here.
Okay, how transfer is no. Okay, how heat transfer is taken over here?
In between the separation.
Okay. Heat temperature is changing, but there is no heat transfer because the heat insulation is over here. So for convection, Joule-Thomson experiment is not an example. Okay. So this is the design-based explanation of convection. Convection is ideology as well as there is a mode of heat transfer through certain liquid outside or thin film layer. Through that heat to transfer. Here there is no ideology of heat transfer because the thermal there is a pyros wall. It's a pyros wall. It has a what I can say. It has a dedicated example like if you couldn't make any heat change, it will supply the what heat is actual that will be supplying over here. Here the heat insulation is there, no heat is exchanged from here. So it is not an example for a convection.
As for the summarize. Please summarize.
when coming to the summarization, this is the Joule-Thomson effect. The Joule-Thomson effect is nothing but changing temperature with respect to pressure. While we are changing the pressure, the temperature will be changing. As an example, this is an hollow object which we are making a temperature. When the fluid passes through it, here the fluid will inside the fluid will take the heat, absorbs, and then when it comes to the outside, then comparatively the diameter is outside surface is coming. So here inside surface area is small, outside the surface area is high. So temperature inside is high, temperature outside is low. So that's the main part the Joule-Thomson is conveying. So like convection is the process which we are taking out the transfer of heat. Transfer of this heat through fluids is the main part of convection.
Thank you. I thank the volunteers for explaining this in the based convection mode of heat. Thank you.